Brandon Clayton, the algebra guy here, discussing, as you see on your screen, simplifying expressions involving square roots. So how do you do that? Really simple today. By the end of the lesson, you'll be able to simplify numerical radical expressions involving square roots. This is TEAG 11A from my Algebra 1 STAR test. So let's get into it. So first of all, let's start with this notation. I'm sure you've seen already and gotten familiar with. A square root symbol right here, which looks like, as you see, and this is kind of cut off because of the way the computer does it, but you got your square root symbol, which is simply asking us the square root of some number, which is the opposite of squaring. So square root of a is considered simplified if a has no perfect squares factors, and we'll talk about that underneath this radical sign. If there's no perfect factors in there, then we're going to consider it simplified. So the square root of 31 is simplified. Why? Because there's no factors that I can break it down into other than 31 and 1. So square root of 31 times square root of 1. I can't figure out any other factors, but square root of 32 is not simplified. Why? Because there's a square root of 16 in here. I could have broken this down to square root of 16 times the square root of 2. And the square root of 16 is a perfect square because 4 times 4 is 16. So the square root of 16 is 4, and that'll give me 4 square root of 2. So this is not 32, is. So here's the product. If a and b are non-negative real numbers, then square root of ab equals a square root of a times square root of b. So, and this is really the only rule or the property we need to know going forward with simplifying square roots, is that you can take a square root and break it into its factors and still have the same thing. For instance, if I had a square root of 100, it'd be perfectly fine for me to break it into factors that multiply to give me 100, as square root of 10 times the square root of 10. Doing this is really powerful and it would allow us to simplify here, as you'll see in just a second. All right, so we have this stuff here on the side, which we're going to refer back to because these are perfect squares. So we use a product property of square roots to remove all perfect square factors from a radical. I'll show you how to do this here in these examples. So for instance, we got the square root of 50. Now you can do this by taking you can break this 50 into any factors you want to, but let me give you a word of advice. It's going to be a lot quicker if you take out the highest perfect factors, perfect factors that exist with this 50. So for instance, I could break it down into square root of 10 and 5, but it'd be more ideal for me to think through what are some factors of 50 that are already perfect squares. So for instance, as I go down this list, I'm gonna start with the highest and move my way up because it's a lot faster if I do it that way. 36 times anything would give me 50? No. 25 times anything give me 50? Absolutely. So if I broke this into square root of 25 times the square root of 2, right? Because 25 times 2 is 50. Well, square root of 25 becomes easy because that's a perfect square. Square root of 25 is, as we see over there to the left, is just 5. And now I'm left with square root of 2. There's no other perfect factors or no other factors for 2, so I'll leave it this way. So my answer is literally going to be 5 square root of 2. So another way of writing square root of 50 would be 5 square root of 2. And you can check this in your calculator. Matter of fact, I'll take out the calculator, and because these are good problems to check as we move forward. Let me erase what we've already gotten. And because this calculator is going to come up again later as we consider how we can work through some of these problems. So let's go here. So the one way I could write this or check this, I'm thinking to myself, well, this is a new idea for me. So let me put in square root of 50 and press enter. And you see that they're the same thing as 5 square root of 2. Matter of fact, if I were to get the decimal form of it, it's going to be 7.07, and as you see. But it would be the same thing if I said 5 times the square root of 2. And I said I wanted that in decimal form. And now I just proved it to you. That square root of 50 and 5 square root of 2 are exactly the same thing. And we just showed how we can get that. As a matter of fact, when using simplifying expressions, many students will just refer back to the calculator to see which ones are equivalent, because that's the degree to which they're tested oftentimes on the test. Keeping my calculator out, let's look at this next one, 500. So the 500 seems like a big number, but when you start looking down your list of perfect squares, you see 100, and I know that 100 times 5 will give me 500, so already I'm breaking this down pretty simply. What is the square root of 100? Square root of 100 is just going to be 10, and that leaves me 10 times the square root of 5. So this is a simplified form of square root of 500. Now, what about square root of 63? So what are the factors of square root of 63 by which there may be some perfect squares in there? Well, let's start here. 36 times something gives me 63. Nope. 25 times something. Nope. 16. Nope. 9. Yes, there is a 9, I remember, because 9 times 7 gives me 63. And I know the square root of 9 is 3. So I'm left with 3 times the square root of 7. Now we'll pause it here and see if you can work these other two before I get to them. All right, so we also have 98 and times what? Well, if you don't know, there's a couple of things you can do. Just go through your calculator and do 98 divided by 2, 98 divided by 3, until you start to see numbers that you recognize. And don't fret even if you know one that's not the highest perfect square, because it still will come out. Like for instance, 98. I don't know. Actually, I think it's 49 times 2, isn't it? So, but what? Let's say we had another one. Let's say we chose 4 work. 2, 1. No, that won't work. I guess I'll try it on a different one. I'll try it on the square root of 80. I was going to say, what if we try one that we didn't pick the highest one? What would happen then, so that you don't feel bad that, oh no, I didn't pick the biggest perfect square. So let's go ahead and pick 49, because 49 times 2 is 98. So square root of 49 is 7, and that's 7 square root of 2. For 80, let's see here. 36, no, 25, 6, it may be 16. What's 80 divided by 16? So let me double check. That's 80 divided by 16. Let's see if that gives us a number. So that's 5. So we can use that. So we know, let's do this two ways. We know that that's at least one of the biggest. So square root of 16 times 5 will give us 80. Square root of 16 is 4, and that'd be 4 square root of 5. But what if we didn't get square root of 16? Let's say we got 80 here, and we knew just 2. Like we know that 2 times 40, for instance. Will we still come up with this same answer? And I would say to you, absolutely. But it's just going to be a few more steps. So I'm going to take this 40 now and break it down further into maybe like 8 and 5. See, there's nothing else I can do with this one. This is a prime that's not going to multiply by anything else. And there's nothing else I can do with this 5. But this 8 still has perfect squares in it. So I can go 4 and 2. And that's a 4. Looks like a 9. So square root of 4 is 2. So this leaves me with 2 square root of 2. So look, it's a little bit more work. So I end up with 2 square root of 2 times square root of 5 times square root of 2. So let me write all that out. 2 square root of 2 times square root of 2 times square root of 5. So if I were to simplify that, what would I get? Well, square root of 2 times square root of 2 is actually 2. So this becomes 2 times 2. This right here becomes 2. 2 times 2. So that's just 4. So now I'm left with, again, 4 times square root of 5. So it doesn't matter. You'll work your way there. So fret not if you're thinking about that. Oh, look, these are some bigger numbers. Let's try to get those perfect squares to multiply here. So what can go here for a 180? I don't know the biggest number right offhand. I want to say 36 is one of them. So let me check on the calculator. 180 divided by 36. Yeah, that'd be 5. So let's try that one. So we'll do square root of 36 times square root of 5. Give me 180. Well, square root of 36 is just 6. and that's square root of 5, so we're done there. 320, I don't know again at the top of my head, but the first thing that comes to my head is 32 and 10. And some students will forget and draw 32 and 10 like that, but please remember to put the square root, because that makes this true, and you may forget whether it's the square root or not. So I know that these are not perfect squares, but I couldn't figure it out in time, and maybe I didn't want to take the time. So I just put it this way. Well, let's break these down into perfect squares that we can find. I know that 16 times 2 is 32, so square root of 16 and 2. I know this is going to give me 4 square root of 2. And what about 10? I know 10 can break down to 5 and 2. So now I'm left with 4 square root of 2 times square root of 5 times square root of 2 times 4 square root of 2. So this is going to be square root of 2 times square root of 2 is 2. This is just going to be 2. So 4 times 2. And then I have square root of 5 on the end. That's the square root of 5. All right, so 4 times 2 is 8. And that'll be 8 square root of 5. So yeah, it took me a little bit more work because I didn't find the biggest perfect square, or I didn't start out with a perfect square. And you could do that pretty easily. Just do 32 and start dividing it by 4, 5, 6, 7, and you'll start to see some of these numbers pop up. All right, 54, let's use a different color. Is 9 times 6, so square root of 9 and square root of 6. Square root of 9 is 3, and there we go. All right, let's look at what it looks like on STAR test. This is not a popular question, but it does come up, so I'll look at this one. So we end up with 2 years ago was square root of 147. That was the question. Which one would you pick? I will pause it here and solve it to figure out which one you would pick. Now, let's start with the way we've been working it, and I'll show you another way to do it. So square root of 147, we know we can put, let's see, 8, that can divide by 3. So 147 divided by 3, 147 divided by 3 is 49. Oh, that helped a lot. How did I know that divided by 3, by the way? So here's a little bonus. If I add up 1 plus 4 plus 7, what do I get? Well, that's 7 plus 1 is 8. 8 plus 4 is 12. I know that 12 is a multiple of 3. 3, 4, 3, 6, 9, 12. And anytime you get a multiple of 3 after adding all the digits, you know that it's divisible by 3. So that was my quick little rule. So there's my bonus there. All right, so I know this breaks down into square root of 3 and a square root of 49, because 49 times 3 gives me 147. So now it becomes simple because square root of 47 is 7, and square root of 3 is just square root of 3. And we usually put the square root after the number, so we'll leave it this way. Bam. Easy to see, right? So no problem with that. Now, truth be told, a lot of students don't go through the steps in the work of trying to simplify it. And I don't blame them. So if there's an easier way to do it, why not? I just want you to know that you can and maybe should simplify it like that sometimes, and it may serve you in the future. But for this particular question, it wasn't necessary, because you could have literally put this in your calculator, square root of 147, and press enter. And how's that going to help you? Well, students, because you guys are so smart, are going to check each answer to see which one renders that same decimal. And sure enough, 7 square root of 3, when you check it, gives you the same answer. So voila, there it is. Why refute it? Why go through those steps? If you can check it that way, you may want to do it both ways, but know that that is available. Now, word of caution to you. Sometimes they'll give you an answer choice that is true, where you'll get both the same answer, and then students are stuck. Well, what they're looking for is if you know how to simplify it at that point. So remember, we sometimes had, let's say 3 square root of 10. So though, actually she did do a different one. So let's say 3 square root of 12. Erase this. So 3 square root of 12. 3 square root of 12 actually still has a perfect square underneath it. How is that? Because it can break down into 4 and 3. And 4 is a perfect square. Square root of 4 can give us 2. So while this may give you the same decimal answer as another radical, it's not simplified. So that's the only precaution I would give you, is if you do get 2 answer choices with the same answer, that means one of them needs to be simplified. So just keep your eye out for that. I think that does it. So did we accomplish our one objective here? Absolutely. We talked about how we can simplify our radicals by breaking it down into like a factor tree, taking out the perfect squares. But you can also, honestly, on the test, most of the time multiple choice, you can check it by just putting in the decimal. My name is Clayton, the Algebra Guy, and I will see you next lesson.